All right, next up we have Paul Novarese coming up to talk to us. There he is. Paul is a senior solutions engineer at Anchor. He has been working in open source software for over 25 years at companies like HP, Red Hat, and Docker, with a background in enterprise infrastructure and operations, high performance technical computing, automation, securities, and containers. Welcome, Paul.
Thank you.
Looking forward to it.
All right. Yeah, again, my name's Paul Novarese. I work for a company called Anchor. We do a lot of work on securing the software supply chain. We sponsor a couple of open source projects called Sift and Gripe. Sift generates a software bill of materials, which we'll talk about. Gripe does vulnerability matching, pretty straightforward. Most people are probably familiar with the concept. What we're going to talk about today are supply chain attacks in the general sense. We'll talk about Log4Shell in particular, just kind of do a real brief look back at it, not anything too in-depth. We'll look at the concept of the software bill of materials, and then we'll kind of tie those together and see how a software bill of materials can help you the next time we have a zero-day attack like Log4Shell. So what are supply chain attacks? I think most people are kind of familiar with this metaphor of the iceberg where your code is at the top, right? And then you've got all of your dependencies and other people's code on the bottom underneath the waves, right? When you start talking about supply chain attacks, we're talking specifically about attacks where the adversary is attacking all of that stuff under the surface, right? They don't care about your app. They don't want to know about it. They don't have the opportunity to learn about it, but all of that other stuff is common to everyone. So when they start, it's very easy for them to kind of practice somewhere else and, find the holes in your application. You'll see these, they're in the news all the time, right? You don't have to look very hard. Every day there's a new one, basically, right? So just type in software supply chain attack and you'll find something, right? So what does it look like practically? You've got, this is kind of like a real simplified version of your application, right? You've got a couple of dependencies. Maybe you're building a Docker image. You've got some kind of base image there. And you know what you're kind of pulling in directly. But all of those components have components as well, right? So there's a bunch of stuff further down the chain that you may not be immediately aware of. It's probably in the back of your head. Or you just don't have any visibility into it at all for a variety of different reasons, right? So you can see one component all the way in the back end of this thing can just lead, down the chain, and all of a sudden your application is vulnerable. And going back to why attackers like these attacks, from their point of view, it's like once they find a hole, right? They basically now all of a sudden have a bunch of juicy targets open up, right? And again, they don't care about your app, your company, whatever, right? They're just opportunistic, and whatever they can find, they'll take a crack at. Okay, so Log4Shell, right? If you don't know I think everybody probably has at least an idea of what Log4j is and what Log4Shell specifically is, but if you don't, it doesn't really matter. It's a zero-day. It's a real common component. This is a widespread attack. We're not going to go into the specifics of the attack other than a couple of things here. Just real brief on the background. This is an old package, this Log4j. It's been around for a long time, but in 2013 it was completely rewritten. That's where this particular vulnerability kind of slipped in. It's been there for a long time. In 2016, this is not directly connected to Log4j, but a paper was presented at Black Hat that actually outlined this exact type of attack. This thing called Jindy, it's a Java naming and directory interface, but basically injecting in there could lead to these kind of attacks, right? So they kind of predicted this. I don't think there was any indication at the time that they had any knowledge of Log4j in particular. It's just a very generic type of attack. Log4j just happened to be particularly vulnerable to it, and also particularly widespread, right? Timeline, there's some, if you download my slides, there's a bunch of footnotes on this if you're really curious about the sequence of events, but it happened very quickly. You'll see there was basically a private disclosure to the Apache Software Foundation, like on November 24th. A patch kind of silently shipped on the 6th, but before the announcement actually went out, people were already seeing attacks and not really realizing what was going on. So first public discussion of this was like actually on a Minecraft forum of all places. People were seeing weird things. Even further back though, Cloudflare went back and looked through forensic data after the fact and noticed that there were exploits going on as early as December 1st. But one other thing to note here, there's actually several different patch releases. It took a while to actually nail this thing down, so just something to keep in mind as we look, kind of retrospectively. It's not a one-shot and done thing, right? You can't count on that next time either. One last thing as far as retrospectives, how much time people spent reacting to this is a lot, right? I know most of the people in here probably had some kind of impact, whether your code was actually impacted or not. You probably spent a lot of time trying to figure out if your code was affected. That's that green line on this graph, the top line. We did a survey, our company did a survey. It's not exactly a huge sample size, about 200 people, but the average was 23 hours, I think, of people spending 23 hours just checking for vulnerability in their own code, in their own applications. Then the blue line there is remediating, and the rest of it is dealing with actual attacks and other activities is at the bottom. But that green line, I mean, one thing to keep in mind, while you're looking for it, that's time you're not actually remediating, that's time you're exposed if you do have an exposure, right? So if you can shorten that, you can get to fixing the actual problem a lot sooner. Okay, so software bill of materials. This is a little bit of a new concept. A lot of people are not super familiar with it. It's kind of getting a little bit of buzz. White House has issued an executive order. At some point in the future, if you're selling software to the federal government, you're going to have to provide one of these things. I'm not super happy with this analogy, but it gets the point across, this nutrition label. The thing here is there's a couple of things about it's more than just the ingredients, right? So the nutrition facts kind of shows you beyond the ingredients, like some vitamins and minerals and all that stuff. But the thing to take away here is, one, these are factual findings. There's no opinions here, right? It's not like, we're not telling you, okay, there is salt in here. We're not going to say it's too much salt. We'll tell you how much salt. It's up to you to kind of determine what your limit is, right? So these are factual findings. There's no judgments in an SBOM, right? There's plenty of room for judgments when we evaluate the SBOM. But we want to keep it factual. We also want to keep it relatively static. So an SBOM should be tied to a particular point in time, if we're talking about like a code repository, a commit. Or we'll talk a lot about container images. Container images are extremely well suited to this, to a software bill of materials, because you can tie it to an image digest. And in an image, when we're talking about container images, everything that is in the SBOM is in that image. Whereas if you talk about a code repository, it's a little dicier because a lot of times, a lot of the dependencies are not actually in the repository. So when you go to build, you may get something different than if you build it, tomorrow. Depending on are you pinning dependencies, are you not pinning dependencies, et cetera, et cetera. But in a container image, that is exactly fixed. The SBOM can be tied to a particular image digest, and we know for a fact, like this SBOM corresponds to this particular image. One other thing, if you read these, I can't blow this up enough, but some of these ingredients are actually lists of ingredients themselves. So like on the pizza rolls here, the first thing on there is tomatoes, but it actually specifies that tomatoes are made up of water and tomato paste. Good to know. But the point is, this is like a nested list, right? So the idea of having list of lists is, a pretty key concept here. It'll come into play a lot. But going back to the fact that these are not a perfect analogy, right? There are going to be additional things in a real software bill of materials beyond just the dependencies. We can talk about things like how a Docker image is composed. What ports are exposed? Do you have a user specified? things like that, right? Things that might be in your Docker file can be examined, measured, recorded. Things beyond that, right? So it's not just the ingredients; it's how they're put together. A lot of other stuff can go in there. Like I said, you can make software bill of materials from lots of different artifacts. It can be from a code repository. It can be from a binary. It can be from a container image. It could be from an entire VM, right? It can be from a running container, right? It doesn't have to be a static, image. You can go ahead and launch a container from that image, generate an SBOM from the running container, and even do things like diff those SBOMs from the container to the image. Is somebody going into your running container and upgrading packages rather than rebuilding the image? You can detect that kind of stuff by diffing those SBOMs. Other stuff in there, you'll see like license information in particular, really good. I mean, so if you're doing audits for that kind of stuff, you can check all those. SBOMs can be really useful for compliance in general, things like PCI, DSS, HIPAA compliance, stuff like that. So there's a lot more beyond just knowing what's in there. Just real quick, you may have seen this if you've done any kind of pop psychology or anything. This is called Maslow's hierarchy of needs. The point of this, I'm not going to go into all the layers, but the stuff at the bottom has to be satisfied before you can move up the hierarchy, right? So before you can think about friendships and self-esteem, you have to secure food, water, shelter, physical safety, right? For software security, it's kind of similar concept. And the SBOM really helps at the bottom of this, the foundation. What's in your software? What are you actually deploying? If you know that, then your sense of the vulnerabilities in that software can be more, you can be more confident in that. You can sign all the software you want, but if you don't know what's in it and you don't know if it's free of vulnerabilities, that signature is not really very valuable, right? So the more data you have at the bottom of this, the more valuable the other layers are going to be. Now, SBOMs aren't perfect. How we put them together can vary. There are tools, like I mentioned, we have one called SIF that will generate these kind of programmatically. But they can only detect what they can detect, right? So in this example here, you've got an app based on Node. Let's say we're using the Node base image out of Docker Hub. This actually is this example specifically came out of the recent OpenSSL vulnerability that was disclosed a couple of weeks ago. I thought it was going to be really bad, but not quite as bad as we thought it was going to be. But in this case, Node in particular was I'm not trying to single them out, but OpenSSL is statically compiled into the Node base image. Scanners don't detect it. There's no trace of it there. And so it's obscured. That's these kind of dark gray boxes there. So this, a typical scanner will detect all of your dependencies, some of the dependencies in the Node base image back behind there, but not all of them. So there's now this concept of kind of the publisher upstream generating an SBOM, exposing that to the downstream consumer that will give that visibility to the things that are in that image that are not easily discoverable, right? And then you can consume that along with the image and use it in composing your SBOM. This also comes into play, like if you're compiling your own static binaries, let's say, right? Some tools, like let's say Go in particular, does a pretty good job of putting the metadata in the binary, and it is discoverable, but not all languages do that. So there are ways of telling your SBOM scanner, like, hey, this artifact is opaque, you're not going to discover it, but here are the things you need to know about it, right? You can supply that data. The point is, not all SBOM, the quality of the SBOM matters, right? So the more information the SBOM scanner has, the better the SBOM will be, the better your evaluation of that SBOM will be. You'll get better vulnerability matches, et cetera, et cetera. Okay, so just tying this all together really quickly, how is this going to improve my life? One, the speed of evaluations, right? When you go to do vulnerability checks, If you have an SBOM, it goes a lot faster. You can do continuous checks. We'll look at this in just a minute. But also that accuracy, right? Providing that more metadata to the scanner, getting a more accurate SBOM will improve the results of the vulnerability matching, improve the results of compliance checks, audits, et cetera. But as far as like vulnerability checks, this is just timing on vulnerability checks, comparing scanning an SBOM versus scanning an actual Docker image that generated the SBOM. So you see there's a pretty big gap here. The bigger the image gets, the bigger the gap gets. So if you can do these that quickly, the advantage is you can do them more frequently. And basically every time you get new vulnerability definitions, you can just run scans on all of your SBOMs without having to go and track down every image, rescan it, re-enumerate all the contents, et cetera, right? So basically through your entire software development lifecycle, you just continuously evaluate these images, right? Maybe even compliance checks, right? Sometimes the compliance standards will change. Doesn't happen too often, but you may get a directive from somebody like, hey, we need to check for this standard, NIST 853 all of a sudden. Or we're trying to do a FedRAMP audit, let's say, and we want to check against those standards. You can just go ahead and check those things continuously. Okay, I was going to do a demo, but those are always kind of dicey. Last time I tried it, everything kind of fell apart. But what I have done is, if you go to my Twitter or Mastodon, there's a link to my GitHub repository. You can download, there's a repo there that has a bunch of walkthroughs where you can generate SBOMs with some open source tools. It'll walk you through like looking at the results and how to integrate this into an existing CICD pipeline. It's pretty easy if you don't have access to a lab CICD tooling. There's instructions on just deploying a real disposable Jenkins container on your laptop if you have Docker Desktop or something like that. There's some additional labs here that I did for DevOps World, which I was going to do a workshop down there. It got canceled because of the hurricane, but all of the labs are done. So you can see some pretty extensive stuff. That's real Jenkins focused. It was for DevOps World, but it's very easy to do these kind of things in just about any kind of tooling. There's also a GitHub SBOM action that, the SIFT project that I was mentioning. It's already packaged up in the GitHub marketplace. Real easy to just drop into existing pipelines. So what it'll look like, this is not very photogenic, but you can see here just like timing. At the top here, I've got like about 170 SBOMs that I generated for just various images. I went through and just I just looked at all these Cyclone DX. That's one of the standard SBOM formats. Found every instance of Log4j with a version number less than 2.15, right? And it took about, I don't know, what does it say, 4 seconds? And that's on like a T2 medium. It's a real lightweight node. So these things are incredibly easy to parse through. And then you can see like a sample vulnerability match there. I just picked out like one of those images and just ran gripe against it and just found all the Log4j components, every advisory that it matched against. One thing to note, all these advisories do publish, if things are, well, not all of them, but some of them do publish, when a fix is published, they'll put that in there. It's real easy if you are doing continuous checks, you can just key on that to, signal, a rebuild is necessary. Hey, let's go ahead and rebuild this. There's a fix available that addresses it. And you can key on whatever, severity, is there a fix available? How long has the fix been out there? Whatever. Again, a lot of examples in those do-it-yourself labs. We're doing pretty good on time. A couple of things, takeaways here, right? Again, I'm just going to hammer on that. Continuous automated security and compliance checks, right? If you can't automate it, you're not going to do it. It's very easy to automate these things. These tools are real small and lightweight. They don't really add a lot of overhead to your existing pipelines. And if you do that, it will dramatically reduce the time spent identifying issues the next time one of these 0 days happens. I actually had a customer, Cisco is one of our reference customers. When Log4j happened, we were scheduled to go to a CISO summit the next week with them. A lot of people pulled out of it because they were in reaction mode to Log4j. Cisco showed up. They did a great presentation on, they had their entire fleet of images remediated within 48 hours, right? I mean, and it was like, I don't know how many, thousands of images, but they were able to identify everything within a few minutes, basically. Once they got the advisory, they knew what to look for. They parsed through everything in, I think, less than an hour and went straight to that remediation action. Next, SBOMs do improve a lot of things. They're not going to solve every problem you have. Like I mentioned there, we just saw, there's a lot of things that are obscure or opaque artifacts that they have trouble with. There are a lot of improvements there. One other thing, Log4j in particular was a really good example because it was extremely well suited to these types of scanners. The Log4j jar sticks out like a sore thumb. It's really easy to find it, even if it's a jar inside another jar inside another jar, it's still easy to pick out. OpenSSL was a kind of the example on the other end of the spectrum. It was sometimes easy to find, but sometimes extremely difficult. There's been a lot of improvements to scanners to find OpenSSL in particular in binaries, but it's not a permanent solution. It's kind of a Band-Aid. There are more permanent solutions. Like I said, getting upstream providers to publish SBOMs, and if you're shipping your software to end users, right, there will come a day where they're going to ask you for an SBOM for the exact same reason. And that last one there, the SBOM is more effective when the maintainer of an artifact publishes one rather than the end user, right? A lot of this activity is at the end user level now, but it feels a lot like blaming the victim in some ways. Like the real activity needs to happen further up the chain. And like I mentioned, that executive order from the White House will create a lot of, once that's all settled, there's a lot of blanks to fill in there. But that will put pressure on upstream projects to do a lot of this work. Are we okay on time? I've got, that's pretty much it. Like I said, if you download these slides, there's a ton of references. There's a reading list. There's, if you want to do more research on all of this stuff. And like I said, the links to the demos are in here as well. Do we have time for a couple of questions? Okay. Yeah.
So I guess to repeat my question, what would you look for as consider a good ingredient versus a bad ingredient?
Yeah, that's a good question. So I don't know that it's really more a matter of what can be detected automatically and programmatically, right? Which is, so when you build a Docker image, during your build, you bring down a bunch of Python modules, right? If those are left behind in the image, if you just publish the image as is, those are easy to find. RPMs or debs or A packages, easy to enumerate. Now, if you get into a case where you're trying to build like extremely slim images and you do like a multi-stage build, you compile some code, let's say Angular or something, and then you drop that artifact into a slim image at the end, that's extremely opaque, right? And you need that ability to say, okay, during the build, we use these components. I'm going to feed all that stuff to the SBOM generator so that the SBOM comes out with actual usable information rather than, hey, there's one binary in here and I don't know what it is, right? So yeah, that is a huge problem today. And there's not a real good standard way to, during a build, like extract those things and feed them into those SBOM generators yet. There's a lot of activity there. So, if you do a real easy build and just leave everything in the container, it's great. Right? Yeah. Yeah, over here.
Hey,
I just wanted to ask you about a certain tension between a couple of your points. Since supply chain attacks exist, why would you trust an SBOM from upstream rather than computing your own?
Yeah. Well, well, yeah, that's a good question. Why would you trust these SBOMs, right? If you're trusting them to use their code, right? But there are ways you can, if it's open source components, someone will presumably, you can do it, right? Audit there and look at their build process. What's in that repo? Does it actually correspond with the SBOM that's coming out, right? You don't want to do that every time, but spot checks are probably enough to keep people honest, right? You do have to put a little bit of trust into these whoever you're consuming this from, right? Now, in the case of, is it somebody you're in a commercial relationship with? They're obviously going to have a lot more motivation. There's probably some kind of legal repercussions if they're deceiving you, right? But for open source stuff, I mean, the real challenge there is not maliciousness as much as carelessness, laziness, whatever. I don't want to, look, I've been in the open source world a long time. Not laziness per se, but just, things get overlooked, right? So yeah, that's a concern for sure. There is a trust element to it, right? But you can, in theory at least, go through and spot check those kind of things and make sure there's at least a reasonable correspondence between what you started with and what you ended up with. Yeah. All right. Any more? One more? No, okay, yeah, there's a link in the references to a great talk a coworker of mine gave at Open Source Summit about, was it a few months ago, I guess, in Austin, about this, and just kind of goes into detail. It's just a concept, really. It's not there's no standard for that or anything like that, but it does illustrate the point that, I mean, a lot of people are talking about, signing images, signing artifacts, and I mean, I can sign anything. It doesn't mean anything other than somebody signed it, right? But if I can sign it along with like, hey, when I signed this, this was the result of a vulnerability scan. This was what was in the SBOM when I signed it, right? Now all of a sudden that carries a little bit more weight, right? So just improving that. Yeah. Yeah. One.
Some of the things that are in there. Not that that's what they're trying to do, but just it ends up in that. How do I take the bill of materials I get it in and ask things out? Because they may not be able to see it, and I don't have a way to validate it.
Yeah, if it's proprietary, yeah. How do you validate those, right? If it's open source, you can do it, right? But I mean, the point of it in that case is not to, it's to really just make it easier. So you don't have to do that kind of stuff. You don't have to go and validate all that stuff. For proprietary software, though, if you're consuming it, right? I mean, you don't have any way of being sure about it. But you don't have any way of being sure about what you're consuming from them anyway, right? So I don't know. It's not perfect, right? No, yeah. It's good to know the limitations of this stuff, right? Yeah, it is a trust relationship. You can make these documents by hand, they're JSON or whatever, but you can absolutely create a phony SBOM. Yeah. Now, is there going to be some kind of auditing authority that will, like, I could submit my SBOM to and have them, like, when I go, if I'm a food generator, right? Food manufacturer, there are private food inspectors, in addition to the USDA or whatever, right, that will come in, like kosher food in particular, right? They'll come in and they'll verify, without exposing your processes, they'll go in and verify them and put their seal on it, right? That could be a possibility, I don't know. But yeah, I mean, there's definitely some questions to be answered. All right, we good on, I think, oh, one more then, yeah. Yeah, for your own stuff. Okay, so one would be, it's easier for your own use, especially if you're just archiving them for internal use, right? It's really easy for you to correct those, right? And make sure they're accurate. You can look at them and say, okay, these are the things that went in there. As far as like the main things, again, I'm kind of speaking from a container point of view just because that's the space I operate in a lot. RPMs, again, all those packages that are there, anything that uses a package manager, right, those are really easy to pick up. The things that are not, but beyond dependencies that are pulled in via pip or npm or Ruby or whatever, gems, those are really easy to pick up. Things that are not C++ libraries, things like that are kind of usually hard. Sometimes those are installed via RPM, sometimes they're not. So those kind of, depending on what ecosystem you're in, how much work you might have to do to make sure the SBOM is accurate will vary, for sure. The scanners are getting better and better. There's a huge list of ecosystems that are supported now. Most languages have some kind of package management at this point, right? So like things like Rust crates or CocoaPods or whatever, I don't know. But yeah, keeping track of things like when you put the image together, looking at your Docker file, what are you, even what steps you're doing. Are you going out and pulling code down from like a random GitHub repo, right, and compiling it? You can detect that stuff. I mean, the scanner can look at that Docker file. It can look at the image itself and look at the layer history of the image and pull that stuff out, right, and see all of those commands that were issued during the build. Now, again, this goes to the question about if you have a multi-stage build, a lot of that stuff gets obscured, right? So you could feed a Docker file to a scanner in those cases, right? So yeah, it's just a matter of what's going into it, what's actually easily discoverable, which is getting better all the time, right? And then what you're gonna have to keep track of, like, what do I need to know about to account for manually? Not manually, but beyond what the scanner can do itself. Okay. Thanks a lot. Hey, I'll be around if anybody has more questions.
That was awesome, man.